Okay, so in this video, what I want to talk about is camber gain. And what does camber gain mean, and how can you use it to your advantage? So what camber gain is, it's the change in the camber of the tires or the wheels as the suspension compresses, okay? So I'm going to focus in this video on rear camber gain, but you can imagine how the same concepts would apply to the front of the car as well, which also affects the steering, okay? So here I have my vintage Kyosho laser, and over here I have my team associated B44. These are set up in different ways. On this laser, it's set up to have a higher camber gain than what I have here on my B44. So for the sake of argument, we'll call this a low camber gain setup, and we'll call this a high camber gain setup. And you can see that if I just show you the back of the tires here, back of the car, as I compress the suspension, okay, you can see the camber angle of the rear wheel becomes more negative, okay? And then over here, as I compress the suspension, the camber angle of the rear wheels is relatively flat. It goes slightly negative, but it's largely unchanged, okay? So this would be low camber gain, and this would be high camber gain. Now, why would I want either? Basically, camber gain allows you to trade off forward traction with side bite, or forward bite with side bite. So if I have a low camber gain setup like this, okay, as I'm accelerating out of a turn, and the weight is sort of evenly distributed left to right across the chassis, but since I'm accelerating, the weight is transferring to the rear, so the rear suspension is compressing evenly on both the left and right sides. In a low camber gain setup, I maintain forward bite because the camber is not increasing as I accelerate, right? Weight transfers to the rear. I have more contact patch with the ground. If I have high camber gain, my forward bite drops, okay? So you can see here, the wheel camber goes more negative, and so I start to lose a bit of the tire contact patch on the outside of the tire, okay? So forward bite coming out of corners, high camber gain gives you less forward bite, okay? So too much camber gain can hurt you there. Where it helps you is in the corners. So as I'm cornering, okay, we'll go to this low camber gain setup here. Weight is transferring to one side of the car. So say I make a left-hand turn, weight transfers to the right, okay? And you can see as the weight transfers to the right here, the wheel itself gets pushed toward the outside wheel gets pushed toward a positive camber, okay? And you can see that here. So if I have an extreme articulation of the suspension, I'll just lift the chassis up here just to help illustrate that. If I have a really high cornering load, what happens is the inside contact patch of the outside tire no longer touches the track, okay? And what ends up happening is I basically just have the middle to outside contact patch or tread of the tire touching the track. And I also end up riding the sidewall of the tire if I have enough chassis roll, okay? And if I start riding the sidewall of the tire, this sidewall will have less grip than the treaded portion, of course, depending on the track you run on. And you risk sliding the car out because now I'm running with basically a slick surface here, and then the car can slide out, okay? So if you find that mid-corner the car is, if you find mid-corner the car is sliding out too much, then that could mean that you do not have enough camber gain, okay? So you may want to increase camber gain. That'll make the car more stable mid-corner at the expense, again, of forward traction, okay? Here, you can see as the camber gain is higher on a cornering load, okay, so weight transfers to one side, the contact patch of the tire relative to the track surface remains, I mean, it's not perfectly constant, but it changes by a lot less than if I have a low camber gain setup over here, okay? So this is what camber gain does, and it's very important to understand how it's helpful, again, for forward bite and side bite. Now, how do you adjust camber gain? You adjust camber gain by changing the length of your camber link. So here you can see On the Laser, these old Kyoshos always had a whole lot of holes here in the shock tower. If I take this ball stud and I move it progressively inside, okay, towards the inner holes, and then I reset my length here of the turnbuckle to get the same static camber, that means I have a longer camber link. With a longer camber link, I will reduce camber gain. So here is a relatively long camber link, camber gain is low. Here's a shorter camber link at the top, camber gain is high, okay? By moving the ball stud up or down, that will change the roll center. I'll get to that in a separate video, okay? But camber gain is just moving this in or out. And likewise, also on the actual hub carrier, maybe you can see here, the B44 has some holes on the hub tower, and also on the Laser, right? You get some holes on the hub tower here. You can move the ball stud in or out on the shock tower or on the hub tower, and it will have a similar effect on camber gain, okay? So this is how you use it to modulate behavior at the rear. One thing that I found myself is if the car is pushing mid-corner, what I can do is increase camber gain. That will actually give me a little bit more steering mid-corner, okay? But again, you lose forward bite, so it is a price you pay. But I found that especially true with the B44 buggy, and it works with other buggies as well. So if we can imagine what's going on up front now, so let's go to the front of the chassis. What happens if we change camber gain at the front of the car? Well, it will change our steering. Now, in a previous video or in a separate video, I talked about bump steer and how you can use bump steer to basically change the angle of the wheel as the suspension compresses under a cornering load, okay? Now, another component of this steering geometry or suspension geometry is the camber gain, okay? So as the suspension compresses, one thing that happens if I have, say, high bump steer, okay, the wheel starts to turn a little bit more mid-corner, okay? But as the suspension compresses toward one side, it's also pushing the actual camber of the wheel out, okay? So if I want to maintain full contact patch of the front tire to the track to get even more mid-corner steering, what I can do is increase the front camber gain. I can do that by, moving this inner ball stud out, or if I have an option on the tower here on the caster block, like I think on the B44, you get a few, like 2 holes here for this setting. You can move that in, or you can move this out to shorten the front camber link. And that will increase front camber gain. So if I were to theoretically run a high front camber gain with a high bump steer, on mid-corner I would have basically a flat contact patch between the tire and the track surface, and the wheel would turn in more aggressively mid-corner due to the bump steer, okay? So that's the effect that camber gain has on steering. So if I have too much steering, I can reduce the front camber gain. That's one thing I can do, okay? And that will alter the contact patch of the tire relative to the ground under a cornering load, okay? Now, similar to the effect of camber gain on side bite versus forward bite in the rear, it does have a similar effect up front. You would probably notice this more on four-wheel drive cars where you're also applying power to the front wheels. So if I have high camber gain up front and I hit the brakes really hard to enter a corner, under high camber gain, both the left and right wheels will go increasingly negative on their camber. That means I'll end up losing contact patch on the outside of the tread as under heavy braking. That means I have less traction on the front wheels under heavy braking compared to a lower camber gain setup. Okay, so that means with high camber gain at the front, I have less stability under braking than a low camber gain setup at the front of the car. Okay, so that's something to think about. It also, and because you have, I guess one thing you could say is less stability. Another way to look at it is to say you just have less front traction. So under braking, if you want to start turning the car, I have less total contact patch to the tire because I haven't turned yet. So both the left and right suspension are compressing equally. So my starting point is a situation where I have less contact patch between the front tires and the track than with a low camber gain setup. Okay? But mid-corner, as the suspension compresses toward one side, high camber gain helps me on mid-corner. So what you can say is if you have high camber gain at the front, you have less initial turn-in under heavy braking, but more mid-corner steering. And likewise with low camber gain, you have more initial turn-in under heavy braking, but less mid-corner steering. Okay? So this is what camber gain does and what it means for the front and the rear. And that's it for now. So thanks for watching.